Well, so our final speaker today then is Baldwin Lorenz from Triton Systems, speaking about Hermes, using DHS USCG SBIR funding to augment ice rescue capabilities. Baldwin?
Thank you, Chris. Good afternoon, everyone. And like Chris mentioned, we're Triton Systems, and we'll give a brief presentation on our DHS United States Coast Guard project, Hermes, hermetically sealed extreme terrain search and rescue vehicle. So this project's aim is to develop a vehicle to help the United States Coast Guard with ice rescue activities. Some of the key challenges brought forth by these search and rescue missions come from a combination of the limited time response for ice rescue itself and the extreme weather conditions commonly present during such missions. For typical temperatures, you can see them highlighted in red on the table there. There is an average rescue window of like 25 to 65 minutes before a rescue goes and becomes a recovery. So to address this particular constraint, our developed vehicle or solution must have high navigational capabilities, both on land, which includes obviously snow and ice, and water, both normal and icy. And on top of that, obviously, it has to also have the ability to easily transition between those two. Some of our more challenging conditions also include waves, ice shelves that we have to, that block our path and we have to go over, very low visibility in some of the storms or blizzards, and extreme cold air conditions. This research and development effort, obviously, as I mentioned, is directed towards the ice rescue endeavors, but there are a lot of other applications where a vehicle that has these capabilities would be a very good asset. Just looking at its performance requirements, RG Exploration is near a perfect fit for the Hermes vehicle and what we're aiming to build. And taking into consideration the dual terrain capabilities for land and sea, this also makes this vehicle a great match for disaster relief, in particular flooding. Hermes also possesses an advantage navigating to or around areas that are hard to reach via land. So one of the other potential applications comes to forest fires. So if you have an accessibility problem for land vehicles and you have any other airborne challenges for other solutions, but this vehicle can present a new potential where if there's a river nearby or there's any body of water, this particular vehicle can use this to navigate to the area of interest, but also benefit from the access to water reserve and be able to help with that particular disaster relief. So here we have some of the images for some of these scenarios that I mentioned. Ice rescue, obviously we know that ice fishing is one of the activities that more often than not can produce ice rescue scenarios. We also mentioned flooding, and this also extends to hurricanes. And another scenario that this would be a great application for comes through earthquakes. So if you have obstacles that fall or infrastructure decay that blocks access to these affected areas, Hermes would be a vehicle that would be able to overcome these obstacles and be able to navigate these multiple terrains to get where you need it, when you need it. So to fully understand what our proposed solution should be, it's very key and very important to understand the current system that the Coast Guard is using to address these ice rescues and the caveats that we need to overcome. So they currently use the Spec Air for ice rescue missions. This one is the top right image. This vehicle is a fan-propelled airboat, and it carries a smaller inflatable vehicle. The Spec Air is the one used for mainly transportation. The Skiff Ice, which is the inflatable smaller vehicle, is the one that is used for the actual rescuing when on site. And we listed here some of the issues with the Spec Air, And one of the key bottlenecks for the current solution that's being used is its difficulty tackling like different terrains. Particularly, it has very poor maneuverability on land, and it has a lot of trouble climbing over ice shelves. Two things that are like crucial when it comes to ice rescues. So looking at these caveats and the current performance of the system, we decided to come up with a design for Hermes. And so what we decided to do is focus on a solution that addresses navigational capabilities for land, water, and the ability to transition the two. And for that, what we decided to do was use CEO's Fat Truck as a base vehicle, since it's already been proven for some of these scenarios, both in navigation and in environment, and use this base vehicle and enhance it in a way that it can address all of those caveats and bottlenecks present in the current solution. To do so, the main change that we're going to do to this main vehicle is going to be the enhancement of the hull itself. So we're going to lengthen and widen the main hull and add a jet drive to this vehicle just to improve its navigation capabilities on water. This additional space would also obviously be used for all of the rescue equipment and making sure that the passenger space is something that is beneficial to our rescuers. So basically putting all of those together, this is a quick list of what we're looking to manage with Hermes, the specs, what we want to be able to traverse, the terrains, the speed, operation time for these rescue missions, temperature, both in water and in air, since one of the issues with the spec air is that, you have cold, freezing air, and sometimes it would get frozen to the ice shelf itself. So being able to address all of these conditions is something that we're looking at with our Hermes vehicle. And moving forward on that, some of the things that we're doing when comparing it to the current and other alternatives, if we compare it to the spec air and the US and a rescue helicopter, what we're looking at is to not only address the caveats of the spec air, but also try to match and find a in-between solution that has benefits over both the spec air and the more expensive to deploy options such as the helicopter. So currently we're deep in the design phase of Hermes. We just finished the required hull extension modifications and the details for the new engine and jet drive.
Yeah, there was a question that came up to repeat the base vehicle.
The base vehicle is the Fat Truck from Seal Motors. Thank you for catching that, James. So as I was mentioning, so we're currently finishing up the hull modifications and adding the details for the new engine and the jet mount drive. The U.S. Coast Guard has been nice enough to get us a list of all the onboard rescue and communications equipment with all the specs, and we're looking into space claims within the vehicle and see how that affects the mass distribution to make sure that our resulting vehicle is stable in both like static and dynamic scenarios. In the upcoming weeks, we'll start fleshing out CAT modifications and potentially adding a second egress point on the roof. On the bottom left image, you'll see a picture of the current state of the hardware. So our manufacturing partner just started doing the base modifications to the vehicle, and our goal and current schedule, looking at our current progress in design and parts acquisition, is to have a prototype ready for our upcoming ice rescue school session that is usually held in winter. This year will probably be held in February. And so what we're looking forward is to be able to have a functional prototype, have performed some tests on relevant environments and conditions, and have people actually operate this and provide us feedback and go through the iteration process to make sure that our design can best tackle the needs of the United States Coast Guard for all of these ice rescue scenarios. So I'll talk a little bit about us at Triton. What do we do? So we've been around for about 30 years now. We have 100 scientists and engineers working in and around 70 different projects. And we have a lot of our wide variety of laboratories and equipment. So most of our efforts are done in-house. Most of our projects are funded by SBIRs for multiple branches of the DoD and DHS. And our main goal as a company is to research and develop different technologies that meet what the government needs, and then together with our selected transition partners, move forward with commercialization. Following this path has led us to multiple projects develop into successful spin-offs. Looking at the skill sets, so we have different groups with different skill sets. Our technical expertise of this particular team that's working on this project, it's the robotics group. So we focus obviously on robotics, sensors, control systems, and overall core engineering. Through collaboration with all of our multiple interdisciplinary teams, we've been able to develop, as I mentioned, a series of different technologies for different branches of the DoD. And we have some pictures on the right to showcase 3 such projects. The top right one is one used for water purification. So the one on the left is used for is an aviator relief system developed for the Air Force and Navy. So for long missions, usually aviators dehydrate to prevent the need for evacuation, but that comes at a cost for the loss of cognitive ability throughout the mission. So to avoid the process in itself and facilitate extended flight missions, Triton has developed a portable bladder relief device designed particularly for female aviators. This device in particular has been tested on multiple test subjects and is in the final stages for design refinement as it enters its commercialization process. And the bottom right image shows our personal air mobility system that once developed with DARPA, and it's a solution that allows and facilitates troop mobility across long distances. This one in particular, if I recall correctly, goes up to 200 miles. So all in all, that I hope that paints a picture as to who we are at Triton, what do we do, and some of the project and technologies that we're invested in and currently working on. And so I'd like to conclude our presentation just going with a quick project overview. So this particular project for Hermes was awarded on April last year. And after a case study and refining the approach concept, we were able to present our approach at a ice rescue conference on October last year. We were able to meet with a lot of officials that would be the ones to use this on the field. And after compiling all of that feedback, we were able to go back, refine our design, and we're looking forward to having a functional prototype for the Ice Rescue School training program that's coming up in February 2024. At the moment, we're requesting a phase 2 enhancement for this particular effort, just to make sure that the goal at the end of this phase 2 is to have the technology developed up to a TRL of 8. So we want to make sure that this prototype goes through the proper qualification and is tested in the relevant environment, weather conditions, and we're able to set it up for success at a low rate initial production. My name is Walden, as Chris mentioned, and over here with me I have James Dean, and we're with I'm the PI for this effort, and James is the project manager. So with that being said, I would happily like to take any questions.